In today's video, we're going to talk about continuity. So the concept of continuity, informally, is a function is said to be continuous over an interval if you can draw its graph without lifting your pencil. So this function here is continuous. We can start at -4 and we can draw our graph going all the way down to +4. So we can, without lifting our pencil, draw this graph. This function is not continuous or discontinuous because when we draw this function, when we get to 0, we have to lift up our pencil and draw the second part of the function. So this function is discontinuous. The function on the left is called continuous. So formally, a function f is continuous at a point x equals c if 1. The limit as x goes to c f of x exists, 2. F of c exists, and 3. The limit as x goes to c of f of x equals f of c. So we can break all of these sorts of things and the function is discontinuous. Now, a function is said to be continuous on an open interval, a comma b, if it is continuous at each point in the interval. So, for example, a polynomial function is continuous for all x, otherwise known as the open interval -∞ to infinity. A rational function is continuous for all x except if the denominator is 0. If the denominator is 0, we've already seen this, there's either a vertical asymptote or a hole in the function. So let's think about some functions here. When are the following functions continuous? So we've got f of x equals x squared minus 2x plus 1. This is a polynomial. So it's continuous everywhere. This function is a rational function. F of x equals x divided by x plus 2 times x minus 3. So this is continuous everywhere where the denominator is not 0. So this is continuous except x equals -2 or x equals 3. We also say this is discontinuous at x equals -2 and x equals 3. Okay, what about these functions? F of x equals 1 minus x squared over x squared plus 1. So this is going to be continuous everywhere where the denominator is not 0. And of course, x squared plus 1 has no real roots or zeros. So this is always continuous. If you're not sure, let's simply use the quadratic formula. -b, which is -0, plus or minus the square root of b squared, which is 0 squared, minus 4 times 1, which is -4, over 2. And this is never 0. We have a square root of a negative number, so there are no zeros. So this is always continuous. And we've taken the reciprocal of that function, f of x equals x squared plus 1 divided by 1 minus x squared. I'm going to rewrite this as x squared plus 1. The denominator is the difference of two squares, so that's 1 minus x times 1 plus x. So this is discontinuous at x equals 1 and x equals -1, and so this is continuous everywhere else. Okay, one of the things we can do with continuity is help us solve inequalities. We are going to do this over and over again in this course, so being pretty good at this is going to help. So we can use properties of continuities to solve inequalities when a function, for example, is positive or negative. So a continuous function can switch signs only when it is 0. This seems kind of obvious, but it's an important fact. And then a discontinuous function can switch signs when it is 0 or when it is discontinuous, right? So there are points where it's discontinuous. We can change signs either there or where a function is 0. Okay, so we're going to solve an inequality. X plus 1 over x minus 2 is bigger than 0. So this inequality, we know this function here, let's write that down, f of x equals x plus 1 over x minus 2. We know this function can change signs only when it's 0 or when it's discontinuous. So the interesting points in this function are going to be x equals negative 1, that's when it's 0, and x equals 2, which is when it's discontinuous. So the way I solve these problems is I'll draw a number line. So we're going to draw a number line. We're going to put our points in the number line, negative 1 and 2. Now we know this function can change signs only at these 2 points, which means that in between these 2 points it's either positive or it's negative. If it's positive, we solve the inequality works. If it's negative, then it's not going to satisfy the inequality. Now, if it's greater than or equal to 0 instead of greater than 0, we have to worry about the endpoints, but we're just greater than, so it should work. Okay, so we're going to look at this region here from negative infinity to negative 1. We have to choose some number in that region and decide whether this is positive or negative. My inclination is to choose a really big negative number, like negative 1,000,000. If I plug negative 1,000,000 in, the numerator is certainly negative, and the denominator is certainly negative. Negative number divided by a negative number means the function is positive. Okay, between negative 1 and 2, I have to choose some number and figure out whether this function is positive or negative. Nicest number here is probably 0. Numerator is positive, denominator is negative, positive divided by negative, negative. Again, 2 to infinity, choose a really big number, like 1,000,000. Numerator is positive, denominator is positive, so the function's positive. Again, we're greater than, so we're not interested in negative 1 and we're not interested in 2. So this inequality is true from negative infinity to negative 1, excluding negative 1, union 2 comma infinity. Alternatively, we could have written x is less than negative 1 or x is bigger than 2. Notation-wise, generally, I don't care. All right, let's solve a different inequality. X plus 1 divided by x minus 2, same thing, is bigger than 1. Okay, now I'm going to solve this in a couple of different ways, and we're going to make a mistake in one of them. First, I'm going to use the same approach I did before. Well, if I want to use the approach I did before, I need a 0 on the right-hand side. So I'm going to rewrite this. X plus 1 over x minus 2 minus 1 is bigger than 0. And let's keep going. X plus 1 divided by x minus 2 minus x minus 2, find a common denominator. X minus 2 is bigger than 0. X plus 1 minus x minus 2, the x's cancel, and we end up with a 3 over x minus 2 is bigger than 0. Okay, well, the only interesting point now is when x equals 2, which is when the function's discontinuous or not defined. I'll draw my number line, put the point 2 on it, and again, we will plug in some number here, big positive number, 1,000,000, 3 divided, that's positive, divided by positive, the function's positive. Put in a big negative number in, positive divided by negative, we get negative, which means the answer is x is bigger than 2. Now let me make a mistake and we'll discuss why it's a mistake. So an easy mistake to do here is I've got this function and I go, well, x plus 1 over x minus 2 is bigger than 1. That means x plus 1 is bigger than x minus 2, which means 1 is bigger than negative 2, which means that this is true everywhere. Everywhere. Now we know it's not true everywhere. We know it's only true for x bigger than 2, so something's gone wrong in this second solution. So this is not correct. And the thing that went wrong is if you multiply a inequality, both sides of an inequality, by a negative number, it switches the inequality to be less than. Right? So if it's greater than here, it'll switch it to be less than. And x minus 2 is sometimes negative. In fact, x minus 2 is negative when x is less than 2, which is this region here that this approach mistakenly solved. All right, some more exercises. Solve the inequality x squared plus 7x x squared plus 7x is bigger than negative 4. Again, let's rewrite so we're greater than 0. X squared plus 7x plus 4 is bigger than 0. We need to factor. I can't see this, so I'm going to use the quadratic formula. We want to know when this function is 0. Well, so we know that's x equals negative b, negative 7, plus or minus the square root of b squared, 49, minus 16. 4ac, 4 times 4 is 16, all over 2, which is negative 7 halves plus or minus, that is 33 square root of 33 over 2. All right, that was kind of unpleasant, but these are the 2 points at which the function can change signs. I draw my number line. So we get negative 7 halves minus square root of 33 over 2, and we get negative 7 halves plus square root of 33 over 2. Put in a really big negative number, like negative a million. On the left-hand side, the x squared term is going to dominate. It's going to be biggest, right? Negative a million squared is much, much bigger than negative 7 million. It's positive, so it's true. Let's go really big positive number. This is positive, so it's true. This function is continuous, so we know it's 0 here and we know it's 0 here. We know this is a parabola, so we expect the function to be negative here. So we think it's not going to be true here. And we can, if we're very careful and clever, like for example, put in negative 7 halves, we'll find negative 7 halves, this is negative 49 over 4 plus, oops, not negative, positive 49 over 4 plus 7 times negative 7 halves, which is positive 49 over 4 minus 49 over 2, which is negative 49 over 4. And that is less than negative 4, so it's not true. So we've got this solution here is x is less than negative 7 halves minus square root of 33 over 2, or x is bigger than negative 7 halves plus square root of 33 over 2. All right, last problem. X minus 4 over x squared plus 2x is bigger than 0. So now we're doing x minus 4 over x plus 2 times x is bigger than 0. The 3 interesting points are when this is 0. So 4, 0, and negative 2. 0 and negative 2 are when it's undefined. Again, usual strategy. Draw the number line. Negative 2, 0, 4. Got to check our regions. Really big negative number. Numerator is negative. Denominator is positive. Function is negative. Really big positive number. Positive divided by positive. The function is positive. Between negative 2 and 0, choose some number. The easiest number is probably 1. 1 minus 4, negative 3 is negative. 1 plus, we're doing negative 1, sorry. Negative 1 minus 4 is negative 5. Negative. Negative 1 squared, which is 1, minus 2 is negative. Negative divided by negative is positive. In this region, choose a number. 1 seems like a good choice. 1 minus 4, negative 3. So it's negative. 1 plus 2, 3 is positive. We have a negative. So here, I'll write this in interval notation, negative 2, comma 0, union 4, comma infinity. So that's how we solve this last problem. Find the places where the function is 0, find the places where the function is discontinuous, and solve. Always make sure on the right-hand side of this equation you have 0.